Okay, so let's discuss some of the questions on photoelectric effect. So before discussing, if you have not seen the previous lecture, please watch that video first over photoelectric effect and then come back to this video to solve questions. Okay. Okay, question number 1. First question, it is saying that stopping potential V1, stopping potential is V1 for wavelength of light used lambda 1, and stopping potential is V2 when we are using the wavelength lambda 2. So they are asking what is the value of V1 minus V2. Okay, question clear. When we are using the incident light of wavelength lambda, stopping potential is V1. When you are using this potential lambda 2, then stopping potential is V2. Okay. Okay, just a minute, let me check. Oh, something is wrong. Which this one? Okay, with iPad Air. Filters, delete. Color correction, delete. Apply let, delete. Okay, now it's all good. Okay, so what they're asking, V1 minus V2. Question is clear. Okay, let's see. So photoelectric effect, photoelectric equation is Hc by lambda equals to phi plus EV naught. So when we are using lambda 1, so you will get Hc by lambda 1 equals phi plus EV1, equation number 1. When we are using lambda 2, Hc by lambda 2, we will get phi plus EV2. They are asking V1 minus V2, so subtract second minus first. By doing second minus first, we will get that E times V2 minus E times V1, phi will get cancelled. We will get Hc 1 by lambda 2 minus 1 by lambda 1. So what about V2 minus V1? So V2 minus V1 will be Hc by E in bracket 1 by lambda 2 minus 1 by lambda 1. Okay, so this is our answer for this problem. Clear? No doubt. Simple and straightforward things are there. Okay, next question. Question number 2. Not when you are using wavelength lambda, so stopping potential is 3V0. Same surface illuminated with 2 lambda, the stopping potential is V0. When you are using wavelength lambda, stopping potential is 3V0. When you are using double the wavelength, stopping potential is V0. What is the threshold wavelength? So what is the lambda naught? Okay, question clear, simple. Again we'll use the same equation, Hc by lambda equals phi plus k EV0, E into stopping potential 3V0, equation number 1. From second one, Hc by 2 lambda equals phi plus EV0, equation number 2. We need lambda naught and lambda naught will come in phi here. Okay. So if you check the option is in terms of wavelength. So wavelength you cannot do anything. Okay. So you will replace V0. Okay. From the first equation, what about EV0? So EV0 will be how much? Hc by lambda minus phi into 1 by 3. From the first equation we got the value of EV0 and we will place it in the second equation. So, we will get that Hc by 2 lambda equals to phi plus EV0 1/3 Hc by lambda minus phi by 3. Okay. Now 5 minus 5 by 3 you will get how much? 2 5 by 3, and hc by 2 lambda, hc by lambda common from here 1 by 2, this 1 by 3 will come this side, so minus 1 by 3. Okay, so you will get 2 by 3. 5 also I can write it hc by lambda naught, and that will be hc by lambda into 3 minus 2, 1 by 6. hc cancel, so lambda naught will be how much? Take the reciprocal, it will become 4 times lambda. So this is the answer of this problem. Okay, is also clear? Question number 3. Assuming photoemission to take place, the factor by which maximum velocity of the emitted photoelectron changes when the wavelength is increased 4 times. Wavelength becomes 4 times. Okay, work function to be negligible in comparison to hc by lambda. So phi is very less as compared to hc by lambda. When the wavelength is increased by 4 times, what will happen to velocity of electron? Okay, what will happen, by what factor it will change? Okay, let's see that. First equation, hc by lambda equals to phi plus, okay, phi plus kmax. Kmax is will be half m v square. So we'll say that hc by lambda minus phi equals half m v square. Okay, but here one condition is given, that phi is very less as compared to hc by lambda. So phi is very small, so while subtracting phi it can be neglected. So hc by lambda equal to half m v square. So we need velocity versus lambda, so we can say that v square is proportional to 1 by lambda. Velocity will be proportional to 1 by root of lambda. This is the proportionality. Lambda becomes how much? 4 times. So when lambda becomes 4 times, velocity is proportional to what? Root over lambda. So 4 extra factor will come. Here 4 will come, and out of root it will become 1 by 2. So velocity will become how much times? Final velocity will become 1 by 2 times initial velocity. Okay. Important, this there is no direct proportionality like this. Okay, under this condition only we are solving, under this condition that phi is much less than hc by lambda naught. So you cannot use it for other different type of questions. Okay, moving towards the next question. Question number 4. Okay, next question says that two identical photocathodes receiving light of frequencies f1 and f2. If the velocities of photoelectrons coming out are respectively v1 and v2, then so when we are using incident radiation f1, the velocity of the photoelectrons is v1, respectively the frequency is f2, then velocity is v2. So these are the maximum velocities. Okay, we work with the maximum kinetic energy and maximum velocity only. Okay, so hf1, hf is frequency energy, that will be phi plus k max. So phi plus half m v1 square, equation number 1. Okay, similarly hf2 will be how much? Phi plus half m v2 square, equation number 2. They are asking velocities, then f1 minus f2 will be how much? Okay, so subtracting first minus second, we will get that h common, f1 minus f2, f1 minus f2 equal to half m v1 square minus v2 square. So what will happen to f1 minus f2? So f1 minus f2 will be m by 2h into V1 square minus V2 square. Okay, also clear? Question number 4. Okay, moving forward to next question, question number 5. They are saying that maximum kinetic energy of photoelectron when light wavelength lambda. So when we are using light of wavelength lambda, so under that condition maximum energy of photoelectron is 1 electron volt. When we are using the wavelength lambda by 3 becomes, what happened man? Okay, so when we are using lambda by 3, maximum energy becomes 4 electron volt. This is not velocity but energy. K max becomes 4 times. Work function of the metal is, so they are asking the work function. Okay, so first equation Hc by lambda equal to 5 plus K max 1, equation number 1. Second one Hc by lambda by 3, so 3 by lambda equal to 5 plus 4, equation number 2. Again what they are asking, work function. So Hc by lambda will be how much? 5 plus 1. So 3 times Hc by lambda. Hc by lambda I will put from the first equation, that is 5 plus 1. So 3 times 5 plus 1 equals to 5 plus 4. So I will get that 3 5 plus 3 equal to 5 plus 4. So this side will get 2 5 equal to 1. So 5 will be 0.5 electron volt. So this is our answer to this problem. Okay, next question. Kinetic energy of most energetic photoelectrons emitted from a metal is doubled when the wavelength is reduced from lambda 1 to lambda 2. Lambda 1 to lambda 2 you are using the wavelength, then what is happening? K max doubled, means you are decreasing the wavelength and maximum kinetic energy is doubling. Okay, lambda 2 is less, decreasing it, so kinetic energy is doubled. The question they are asking is the work function of the metal is, so what is the work function? Okay, now first you are using lambda 1, so Hc by lambda 1 equals to 5 plus K max, equation number 1. Okay, second when you are using second wavelength lambda 2, you will get 5 plus 2 K max. Okay, so what we can, they are using work function, no, so K max we will calculate from the first equation. From this equation we will get the value of K max. So K max how much? Hc by lambda 1, Hc by lambda 1 minus 5. Putting this K max in the second equation, we will get Hc by lambda 2 equals to 5 plus 2 times K max. K max Hc by lambda 1 minus 5. Okay, Hc by lambda 2 minus 2 Hc by lambda 1 equals to 5 minus 2 times 5. Okay, so here minus 5 and I will take this negative, so it will become Hc common 2 by lambda 1 minus 1 by lambda 2. So you can take the LCM also and solve it. Hc in bracket 2 lambda 2 minus lambda 1 upon lambda 1 lambda 2. This is our work function. We are using wavelength lambda. Okay, the fastest photoelectron has a de Broglie wavelength of lambda d. Means when you are using incident, this is our radiation. Okay, wavelength for radiation. Now when we are using the wavelength for radiation, in that case, whatever the electron is coming out, the fastest electron has this de Broglie wavelength lambda d. A change in wavelength of the incident light by delta lambda results in change delta lambda d in lambda d. So, if lambda changed by delta lambda, then lambda d will change by delta lambda d. So, what is the ratio of delta lambda d upon delta lambda? Okay, it is JEE Advanced Question 2017. Okay, let's see then. Hc by lambda you are using. Okay, Hc by lambda will be equal to phi plus k max, and kinetic energy, maximum kinetic energy will be given by half mv square. Okay, now we know that lambda is given as, or de Broglie lambda is given as h by mv. Okay, mv. So let's see how I can convert it. So wavelength lambda equals to phi plus mass I will multiply, so it will become m square v square by 2m. Okay, va? Clear? Hc by lambda equals phi plus mv square. Mv will be how much? H by lambda d. So if I take mv out, h by lambda d. So it will become mv. So h square by lambda d square. Okay. Now differentiate this whole equation. Hc 1 by lambda square is 1 by lambda is there, so it will become minus 1 by lambda square into delta lambda or d lambda, that will be equal to phi 0 h square. Okay, h square lambda d. So when you differentiate it will become lambda d power minus 2, so minus 2 will come out upon lambda d power 3 into delta lambda d. Okay, okay. So now we can say that they are asking what? Delta lambda d by delta lambda. This is what we need. Now question is clear. H one time it will get cancelled. So delta lambda d this side divided by delta lambda this side, it will go this side. Okay, so lambda d cube will go this side divided by 2h. Here what we'll have, here we'll already have in the denominator lambda square. Okay, c is also there, so c will also be there. They are asking basically proportionality. So delta lambda d by delta lambda is proportional to what? Lambda d cube upon lambda square. So this is our answer of this problem. Okay, differentiation part is a little bit difficult, but if you just focus it once, you will able to understand easily how I have differentiated it. This is the equation that I am differentiating, and after differentiating I will get this expression. Instead of d I have taken delta, so no problem. Next question, question number 8. Radiation of frequency f falls on the surface of metals. Stopping potential versus frequency. Graph is given here, stopping potential versus frequency. V naught versus frequency, angle theta, this is 25. Second also given, angle theta, this is 200. They are asking ratio of work function. Phi b upon phi a will be how much? This is our B graph and this is for A graph, work function. So see here. Now at what frequency this photoelectric effect is starting? 25. So that will be stopping potential, stopping frequency for this one, sorry, threshold frequency for this one and threshold frequency for B. So phi B, if I talk about, it is given as H into F. So its frequency will be how much? 200 upon 25. Answer will be 8 is to 1. Simple answer. Clear? Graph is given. Stopping potential versus frequency graph for two metals M1 and M2. Okay, this angle theta 1, this angle theta 2. So they are asking which of the options are true. Theta 1 greater than theta 2. Work functions are same for both them, means greater than, less than, or equal to, all these things. Okay, about theta and work function they are asking. So we know that whenever we draw the stopping potential versus frequency curve, the equation is how much? Equation is stopping potential will be how much? H by E into nu minus phi by E. Okay, H by E nu minus phi by E. Okay, slope will be how much? H by E. So slope does not depend on metals. So its slope H by E nature of metal पर depend नहीं करता. It will not depend on the nature of metal. So both the slopes are going to be parallel. So theta 1 must be equal to theta 2. Okay, ba? Theta 1 equals to theta 2. Now work function. Now for work function you will see the intercept. Which one is having more intercept? Second one is having more intercept, and here intercept will be phi by E. So more intercept means more work function. So for the second one, work function will be more than the first one. Okay, simple graphical problem. Next question. Question number 10. Two photons of energy is twice and thrice the work function of a metal. So we are using two photons, photon A, photon B. Its energy is 2 times phi and this energy is 3 times the work function. Okay, twice and thrice. Then the ratio of magnitude of maximum velocities of photoelectrons emitted. Ratio of velocities, maximum velocity of photoelectron means Vmax in 1 upon Vmax in 2 will be how much? Okay, let's see. First one, that is energy 2 phi. We are using 2 phi energy. That will be equal to phi plus K max means half m Va square. Question number 1. Okay, second one we are using how much? Thrice 3 times more energy than the work function. So 3 phi work function phi plus half m velocity how much? Vb square, equation number 2. Okay, so now we can simply divide them, phi taking this side, so it will become phi and this will become 2 phi. So phi by 2 phi 1 by 2 equals to half m cancel, Va square by Vb square. So what about their velocities of A and B? 1 ratio root 2, and that is our answer of this problem. Clear? Okay.